Okay, my friends, welcome my YouTube channel. This is I will explain about equilibrium. So, what is chemical equilibrium? Chemical equilibrium is an alternating reaction state in which the reactant reaction rate and product are the same and the concentration of both remain. Chemical equilibrium occurs only an alternating reaction in which the rate at which the reactant is formed is equal to the rate at which the product is formed. The characteristics of the state of an alternating reaction are we got as follows: 5. 1. Occurs in a sealed container at a constant temperature and pressure. 2. The reaction goes on continuously in two opposite directions. 3. The reaction rate to the reactant is the same as the reaction rate to the product. 4. The concentration of product and reaction remain. And 5. Occurs microscopically on the particle material. Next, evaluate a pressure and volume chemical equilibrium. When the pressure on the system pulse or volume is reduced, the equilibrium reaction will shift toward the similar number of molecules. When the pressure on the system is reduced or the volume is increased, then the equilibrium reaction will shift toward the larger number of molecules. Pressure and volume inversely proportional. If the pressure on the system is added, then the equilibrium reaction will shift to right, because if the pressure is added, then the equilibrium reaction will shift toward the similar number of molecules E2. If the volume on the system is reduced, then the equilibrium reaction will shift to the right, because if the system volume reduction, the equilibrium reaction will shift toward the similar number of molecules E2. If the pressure on the system is reduced, then the equilibrium reaction will shift to the left, because if the pressure is added, then the equilibrium reaction will shift and toward the larger number of molecules E4. If the volume in the system is added, then the equilibrium reaction will shift to the left, because if the system volume is added, then the equilibrium reaction will shift toward the larger number of molecules E4. The next effect of temperature chemical equilibrium. When the system temperature is raised, the equilibrium reaction shifts toward a reaction that requires heat. When the system temperature is reduced, then the equilibrium counter will shift toward an heat release agent. Example, in the equation of the reaction, concentration E plus concentration B, consider concentration C H equals minus X. Concentration C is an exothermic reaction and concentration E plus concentration B is an endothermic reaction. If the temperature is raised, then the equilibrium reaction will shift to the left, because if the system temperature is increased, then the equilibrium reaction will shift toward the reaction that requires the heat. If the temperature is lowered, the then equilibrium reaction will shift to the right, because if the temperature of the system is raised, then the equilibrium reaction will shift toward the reaction that releases heat. The next, the law of chemical equilibrium. The law of chemical equilibrium, or the equilibrium constant, is the ratio of the product of the concentration of the product of the received coefficient ring with the concentration of each of the respective concentration reactants. The regular stability constant is symbolized by K or Kc. And the next, heterogeneous equilibrium. In equilibrium heterogeneous equation, the substance involved in the reaction are not equal, so that taken to determine the equilibrium constant in the concentration of the substance whose equilibrium constant is ever E the solution and the gas homogeneous equilibrium. Thank you so much for watching.